Alright, this is Mr. Gillum, and today we're looking at Lesson 16, Day 5 in your instruction book, and we're writing and evaluating expressions. It says, during a car trip, Latasha drives 65 miles per hour for several hours. Now, when it says for several hours, it's not specific as to how many hours that she's driving. It then says that she stops for gasoline and then drives 40 miles more. Write an expression to show how many miles Latasha drives in all. Use your expression to find how many miles she drives in all if she drives for 3 hours before stopping for gasoline. So nowhere in this entire example is there any question marks, so you need to be a careful reader to make sure you answer every part of the question. The first thing we need to do is we need to write an expression. We also need to figure out how many miles she drives in all. If she drives for 3 hours before stopping for gas. So this is the information that we have, and when we're talking about expressions, we don't need equal signs. And so we know that she drives 65 miles per hour for several hours. So when I think about that, I think about, okay, well, if she drove for 1 hour, that would be 65 times 1, or 2 hours, that'd be 65 times 2, or 3 hours, that'd be 65 times 3, or 4, or 5, and so on. And so when I think about her driving 65 miles per hour for several hours, this represents the hour, but we don't know what that is. Okay, we don't know how many hours she's actually driving. And when we have an unknown, a lot of times we use a variable. And so in this case, if she's driving 65 miles for an unknown amount of hours, then she stops for gasoline and then drives an additional 40 miles more. I know that we need to add another 40 miles on top of that. So depending on how many miles or how many hours that she drove initially is going to depend how many total miles that she's driven altogether. So my expression is actually going to be 65x plus 40, or 65n plus 40, or it might say 65m for miles plus 40. I'm not sure what it says in your book, but that's going to be my expression representing how far that she traveled. Now, if she really traveled for 3 hours before she stopped, we can use substitution to decide how long she was, or how far she was actually driving. So 65, and when we substitute, we always use empty parentheses plus 40. Where the variable used to be, I'm going to use the number that I know represents 3 hours. So in this case, x represents hours. I know that she was really driving for 3 hours, so I'm going to put a 3 in there. And I'm going to follow order of operations. Please excuse my dear Aunt Sally or PEMDAS or however you remember it. So anyway, I look inside the parentheses to start my order of operations, and there's no operations in there. That tells me that my parentheses are no longer necessary. And because 65 is squeezed up right against the 3, I know that's a multiplication. 65 times 3 is, let me think about that, 195 plus 40. Multiplication happens before addition. 195 plus 40, 235. So she drives a total of 235 miles. And I think that one was already worked out in your book for you, but that's kind of how I reasoned through that one. It says Georgia is 2 years younger than 1/3 of her Aunt Micah's age. Write an expression that describes Georgia's age. How old is Georgia if her Aunt Micah is 27? And so this one does have a question mark, so it's very specific about what we're trying to figure out, but it also has a statement that says you need to write an expression, and then we also need to figure out how old is Georgia. Okay, so we have two things to accomplish again, and so here's what we're going to do. So when I think about age, I'm thinking about going farther and farther from 0 in the positive direction. So if I am 3 years old, then I am positive 3, because there's a space of 3 that's gone by. If I'm 30 years old, then 30. Positive 30. I'm never going to have a negative age. However, if I said I am 2 years younger than 30, then I would actually be moving backwards, and that indicates subtraction. So if I was 2 years younger than 30, then I would be 28. So when it says the word younger, this actually reminds me of subtraction. And she is 2 years younger than 1/3 of Aunt Micah's age. Now, we don't know what Aunt Micah's age is, and so in this case that's going to be our variable. It says 1/3 of Aunt Micah's age, so 1/3 of indicates multiplication, Micah's age, which we don't know, so I'm going to call the unknown x again, and that represents Aunt Micah's age. Now I know that Georgia is 2 years younger than 1/3 of Micah's age, so that much and if we're talking about 2 years younger than that, if she's this old, then we want 2 years less than that. And again, less than is one of those words, those phrases that even though we maybe say 2 less than, we're actually saying subtract 2. And so the order of how we say it is different than the order how we would write it in mathematics. So this is my expression where it says write an expression. I don't have an equal sign, and I know the unknown x is how old Aunt Micah is. It says how old is Georgia if Aunt Micah is 27. So really what I'm thinking is what is 1/3 of 27? So what I'm going to put in for x using substitution. Again, with PEMDAS, I'm thinking simplify anything in the parentheses first, and because there's no operations in the parentheses, no add, subtract, multiply, or divide, I know that those parentheses aren't really necessary in this case. So 1/3 times 27 minus 2, or 1/3 of 27. Some of you may know that 1/3 of 27 is 9. Others of you may have to write 2 fractions, multiply straight across. Others of you may cross reduce. 3 goes into 3 once and into 27 9 times. So really what we have here is 9 minus 2. So I know that Georgia is really 7 years old. Okay, so the expression that they used in the book wasn't 1/3 times the letter. It's actually m divided by 3, because I guess the rationale would be if we want 1/3 of something, we really need to divide that by 3. So that would work as well. We could have had the expression x divided by 3. That would represent 1/3 of her age minus 2. And then it would maybe be a little more aesthetically pleasing to have 27/3 minus 2, or 9 minus 2, which would give us the solution of 7 as well. Georgia is 7 years old. Shane buys 3 books. Each book is the same price. He also must pay a 35-cent tax on each book. Write an expression to show the total cost of the books. If the price of each book is $5.15, how much does Shane spend in all? So again, we have 2 things that we need to do. We need to write an expression, and we need to know how much he spends in all. So I guess what we don't know initially is the price of the book. Okay, later on we're going to call each book $5.15, but right now we don't know the price of the book. We don't know, and so we're going to call, that's where my variable is going to be. That's my, we're not sure on that one. So what I have is this. I have 3 books and I'm purchasing them all, and they're all the same price. So if I had 1 book at a certain price, it would be 1 times that price. If I had 2 times the price, that would be 2 times the price. I mean, it's just really 3x. 3 books, each of them cost the same price, so 3 times that price would represent the total cost of the books. He must also pay 35 cents tax on each book. So because he's buying 3 books, he must pay 35 cents 3 times. It says to write an expression to show the total cost of the books. So this could be tricky, and the book's going to represent this in a little different way, I think, and it sticks out to me because I've done this a lot. But really what we have here is a multiples of sums or some factoring to do. This expression would be appropriate, but what the book is actually asking you to do is it would say that we have 3 books, and the book costs this much, and the tax costs this much on each one of them. And so initially when I thought about this, I thought of it like that, but really they share a common factor of 3, and I could use the distributive property to rewrite this as 3 times x plus 35 cents. And that would be fine too, because really we're 3 times however much the book costs and another 35 cents for each of those books. So either of those expressions would be fine. I think this is the one that the book is going to want you to use. 3 times the cost of however much the book costs plus another 35 cents, which would be fine. So we have written an expression to show the total cost of the books. Now that we know that each book is $5.15, we can figure out how much he spent in all. So where the x used to be in either of these expressions, I need to replace it with $5.15. So if you wrote this expression, we could say 3 times 5.15 plus 35 cents. Or if we use this one, we could say 3 times 5.15, oops, plus 3 times 35 cents. And we should get the same answer either way. So one of the benefits of writing it like the book would be that you have a little bit simpler in order of operations. So we can do what's in the parentheses first. 3 times $5.50 And then because there's no operation in the parentheses, really we just have 3 times 550, and that would be $16.50. Okay. If we did this way, again, we could do the same type of thing. We would really have $15.45 here, and we would have another $1.05 here. Oops, I shouldn't put the dollar sign when we're doing our expression here. Sorry about that. And so again, you would get $16.50. So either expression would be appropriate, and you can see if I use the distributive property, we would end up with the second expression too. But either way would be appropriate. Oops, sorry about that. There we go. Oh. So 3 times b plus 4.35. So the book did want you to use this one. So a total of $16.50. Christy alters a skirt. She cuts 7 inches off the bottom of the skirt and then adds a 5-inch ruffle to the skirt's remaining bottom edge. Which expression best represents the final length of the skirt? So let's draw a picture here. She had a skirt and she chopped off 7 inches, minus 7 inches off the top, but then she put 5 inches back on, 5 inches. And so it's asking us which expression best represents the final length of the skirt. If I'm taking away 7 and then putting 5 back on, really what I'm taking away is 2. So I chopped off 7 and I put 5 back on. Really all that changed was just 2 inches worth. So if I had this little mini skirt now and then I put ruffles on it and I add 5 inches on there, I took away 7, I added 5, so altogether I'm subtracting 2. So Evan chose D as the correct answer, which is incorrect. We know that the answer should be C, S minus 2. We take away 7, we add 5 back on. We've actually gotten a total change of minus 2. S represents the length of the skirt. So one way that he could have gotten that answer would be writing the expression as S minus 7 plus 5, which would make sense. S minus 7 plus 5, which I like his expression. His expression is good. But then he simplified it working from right to left instead of left to right. So addition and subtraction needs to happen from left to right, order of operations, and if you add these two numbers together, 7 plus 5, that makes 12, and so I could see where he would get this answer, but common sense in this picture here would dictate that really he's only changed 2. He's only gotten 2 shorter, so 2 inches shorter. So we're going to learn more about adding and subtracting negative numbers later, but just make sure you're doing your adding, subtracting on the same step from left to right, or your multiplication division on the same step from left to right. So that's it for today.